Good night, students. How are you?
Good night, sir. Um, Sorry for not showing up yesterday. I had some connection issues that weren't resolved until this afternoon.
Okay.
So I've been looking over some of the notes to send.
Right.
You saw the two documents that I sent in the group chat, sir?
When is it? And today?
No, I sent them
Oh yes, I did. Some past, some questions, right?
I was basically I was looking through the course outline for unit
Yes.
one, and
Yes.
I was basically like say reviewing things.
Right.
Um I because when I went through it, I was at the I reviewed like say the errors,
Mm-hmm.
and then going on the list, and then I figured I would post two documents that I found.
Yeah, man. I saw those and I appreciate it. I saw them.
Okay.
I appreciate it. Very good. Um, your teachers are honest. Um, I just had a 2 hour class a while ago, and I feel beat out, so tight. And I just imagine how beat out you feel to know, so wow, you had work today, just like me, and you also had a 2 hour session before my class, just like me. So you have two sets of beat out people, one the teacher and two the students. But guess what? We are going to be working together for the common good of adding some more to our content so that we can, you know, say that we would have learned and know it's rough. And I'm actually building up for something because I know I sent you all something today. Yes. When was class? Class was yesterday, done.
There was a class yesterday, sir.
Right. So I would have
Yes,
sent
sir. We had classes.
yeah, right. So I would have sent you something. I would have sent you something today, this morning. Um, so I I know some of you would have had a difficulty accessing the document and going through the document the way I want you to go through the document. So I'm not here to beat you up because I know how I'm feeling. I know how I'm feeling tonight. Um, and I just imagine how you are feeling too. So I'm just gonna ask a question and then move along.
Sir, to be honest, I'm just trying to go through and understand
Mhm,
because I had missed, as I said, I missed class last, the previous class and probably half of the one before. And
mhm.
I went through the document, but I didn't understand until last night. So what I'm trying to do is go do the question multiple times so I can get an appreciation of what is required to be done. So that's what I'm
Very good.
based.
Very good. Very good. Very good that you understood it last night. So it's where I'm going. Now based on what I had planned to do tonight, based on how tired I'm feeling, I don't think I want to beat up myself too much to go and introduce a new topic with you just yet. What I want to do is to spend some time finally tonight. Finally tonight, meaning that I'm finishing off Newton Raphson tonight. Well, actually, I've completed Newton Raphson. Newton Raphson is finished. Finished from last week Wednesday. But what I'm doing is just giving you questions so as to concretize your understanding. So this is the night when you want to roll up into turn chatterboxes because you're going to be verbalizing to me tonight the issues that you may be having, what it is that you're not following, etc., so that I will be in a position to assist. I sent a question tonight, this morning to you. It's going to be, it is, it is almost an ugly question because it has the exponential function in it. And then I hear somebody saying, yeah, so the teacher then come and them always give the easy one in the class and then after that running give the hard one to sit down and do by yourself. Nothing of the sort. It follows the same rule, the same procedure. You're going to differentiate the function, then again substitute into the function, into the differential, and into the original function. Always remember, it is original over the differential. It is always original over the differential. And of course, you're going to subtract all of that from the previous iteration. So I'm going to go through that. No, you're going to go through that. We're going to look at it. But what I want to do in the next couple of minutes, maybe about 20 minutes thereabout, is just to have a conversation, a very candid one with you, about what it is that we would have done, what we would have done, or better yet, put it this way, I'm going to give you an opportunity to tell me what it is that you're not understanding. And if you don't say anything to me, I am not going to be going through the stuff because I'm not going to be reteaching what I would have already taught. If you have a question, put your question on the table so I can do the explanation to it. If based on the handout that I would have shared with you, if there's something in the handout that you're not understanding, I will give you sharing privilege. Share the handout because you all have the handout. All right. Sometimes once I send up the handouts, I just delete that section of the handout. So if you have a question, ask me. Share the handout so I can give you full some understanding, explanation to what is happening right here. And then, but if you don't, I'm not going to be reteaching. And if I go to my handout, it means that I'm going to be reteaching, and I don't have time for that. I want to see now, I did that reteaching yesterday. Having done that yesterday, I want you now to be able to ask me the questions. And then we're going to spend a little bit of time to look at the question that I gave you for homework. And then I may find another question. And if time permits, I may just roughly introduce a topic that I'll develop further next Tuesday, God's willing. So I'm all ears. What questions do you have of me? Go ahead, please.
So the only thing I'm not understanding is the question of the
You're not understanding what, hon? The question was what?
the question that you said this morning.
You're not understanding that one. All right. So I'm going to leave that for now because I will end up working through the question with you tonight. So,
Okay.
but you're understanding everything else, right?
Yes, sir.
All right, cool. Thanks, hon. Are there any questions, guys? You have sharing privilege. Share your document. Share exactly what it is that you're not seeing, so I can explain it to you. Your classmates can benefit from it. If there is none, then I'm going to just move straight ahead and assume that you are understanding. This is your grand opportunity to say to me, sir, this is where I'm not seeing, this is where I'm not understanding. If not, I'm going to move. Speak now. Or forever hold thy peace.
Yes.
Go ahead.
Yeah, before we move on. So yeah, I've been looking at the application of wait, no, that's the wrong one. The Newton one, sir. That's the one I'm talking about. Because I just saw that one recently, and I would basically like you to explain how that one particularly works.
Share your screen. Can you share your screen?
Yeah, I can.
Share your screen and show me exactly where you're talking.
You see my screen?
Yes, sir.
Okay. So I just saw when I just got back the connection, this was one of the newer documents that was sent apparently. So I've been looking through it basically, and I more or less want a synopsis of how this theory works basically.
Okay. So you see what is in red or pink?
The formula, which will be x to the subscript plus 1 is equal to x subscript n minus f of f of x subscript n over f differentiate x subscript n. That's there.
Mm-hmm. You need to know that. No, don't move the screen. Don't move the screen.
Yeah.
Because what it is that I'm going to be explaining to you now is going to be, thanks for being kind. It's going to help somebody else. It's going to help somebody else. No, you see that formula? It must be known, must be studied, it must be remembered. You won't be getting a formula sheet in the exam. Those things are things of the past. You don't get a formula sheet in the exam. So all of that you must know. You must know. You must know. You must know. X to the n plus 1. N is going to be an integer. N is an integer. So what is going to happen is, if I'm finding my first iteration, there are several things to do when I'm finding my first iteration. If the intervals are given, I'm going to find the midpoint. Meaning I'm going to add the first interval, the first value in the interval, to the second value in the interval, add a pair of them, divided by 2, and that's going to be my first iteration.
Okay.
Please be reminded that some questions, some textbooks, maybe even on Educasor, or if you're browsing the internet, they will refer to the first iteration as x0, x0. All right?
Okay.
In others, they will refer to the first iteration as x1. So just be very careful. I use the convention of referring to the first iteration as x1. One because it's the first, and the second iteration as x2, and so forth and so on. But some textbooks use, instead of saying the first iteration, they call it the initial iteration. And the initial iteration is 0. And let me give you an example of what that is. I don't know if you remember when the first case of the first person, they call it case 0 of COVID that came into the island. And you hear them talk about case 0?
Yes, yes. I heard it at when
Yes,
on the
sir.
radio.
Yes, sir.
Yeah, man, case 0. The first, and they believe that this case 0 was the lady who came in from America or England, one of them. And she went to a funeral and she did a cough. Anybody remember this story?
Yeah,
The room?
England,
Yeah.
sir.
In
England.
England. Now, just imagine how made it feel, because one of our students worked at one of the airports and came into contact. I remember, me the teacher student, and have the students in my class. So kill me dead, so me they have COVID. Oh, you couldn't tell me I have COVID, man. Kill me dead, me they have COVID. And kill me dead, me say, this is it, Jesus. The mind is so powerful. The mind is powerful. The mind is very powerful. Yeah, so we call that case 0. The initial one. The initial one, we call it case 0. I use that example to explain to you the significance of sometimes them using the first iteration as x0, x0. All right? And then the second iteration, they call it x1. Please do not be confused if they use that convention.
So they will either say the first iteration or the initial iteration.
Sometimes they give you, sometimes they will say to you, where the first iteration, comma, x0 is equals to 1.5. So so them don't call it x1, them call it x0.
Yeah.
So when you go to x1 now, don't get confused and call that the first iteration. That will be your second iteration. Am I clear, class?
based on what you're saying,
Mhm.
in the context, and how they choose to spin it, they could say, solve the formula for the first iteration using we call it basically x0,
Mhm.
and they give you the expression, and then they will say the first, and then say after that find the first one, and then the second one, and then the third one, basically.
Right. So the first one is going to be x1. No, the second one is going to be x1. I'm sorry, in that case.
Yes.
And the third one
Second
is going to be x2.
one, yes.
And the fourth one is going to be x3. So I'm saying you have to be very careful in that sense where you don't get confused with that. How I do my question, I give you x1 as a first, x2 as a second, x3 as a third. But I'm just showing you, matter of fact, I'm going to give you a question like that one of these days so that you can see exactly what is happening so that you don't get confused. All right, where is it in that document you had a problem?
Now I'm just looking through.
Yeah, so while you look through, one of the things that we must do is an application to differentiation question. So you must differentiate.
Mm.
You must differentiate.
Yeah, when I was doing my review, like say when I was finding like say the errors, yeah, that's what I call it. The not percentile, the increments here. That's the thing. When I was looking through that, one of the first things that I had to do in solving it was like say, well, this isn't related to this, but one of the things that I had to do in that particular one was to find a quadratic was to find the quadratic in that differentiation, and then once I did that, I could substitute it into like say how the error percentage between like say 1.99 to like say 2.00, and I would find like say the answer that way basically. But it's an unrelated thing though.
All right. You say error percentage. Error percentage for what though?
No, this is a separate thing. Increments and errors basically. That was one of the,
Oh,
yeah,
that's a different topic.
yeah.
Oh, okay, that's a different topic. All right, cool. All right. Any other questions that you may have? Any other questions that you may have? Please speak up now.
I'm just waiting for the question.
You're waiting for the solution to the homework question, right?
No, I'm not waiting for the solution. I'm waiting until we go through it together.
Oh, so you want me to get together, go through with it with you, right? That's what they say.
Yes.
Same difference. All right. How many of you have given an attempt to the homework question though? I'm not asking if it's right, I'm just asking if you have given an attempt to the question. How many? Nobody? Everybody look at it and say, look hard and don't read.
Amen.
Yes, sir.
Mr. Jones, please save me for the night. The teacher is tired. Tell me that you did the question, Bijan. In the beginning of the class, in there, Crosby.
Yes, sir.
OSP.
Good, sir. Oh, good.
So that you did the homework then, right?
No, sir.
I know, good then.
Sir.
Uh-huh.
Yeah, there weren't any fires in your area.
Fires?
Yeah, like brush
Bush
fire.
fire?
Yeah.
Like every week.
That was partly why I wasn't able to come to class yesterday. Because some people where I live in the country, like as I said before, and people usually like bush for like say for them make way for them goats.
Mm-hmm.
And sometimes they forget for out the fire. and and the fire service they have come in and let's say the fire near Georgia. It's near where I live.
Mhm.
It reached the extent where like so the fire they reach near the cable wire them and then burn up.
I don't understand these people though, because I mean, um, the, I got up this morning and I started to cuss because the people around just continue to burn, and it is frustrating. I cannot. When I smell smoke, I get sick, and I don't know. People are just selfish. There are times I will get home and I will look and I see fire on the hill,
Yeah,
and
that.
and then know the ash that comes down is becomes a nuisance, and people are just not neighborly, and if you talk to them,
Them will
you
cuss you.
know they
Yeah,
cuss
them
out
cuss
the
you and
daylight.
I
Yeah,
say
man.
like stuff in business.
Yeah, man. I mean, I remember one day, Crosby, my neighbor, I'm in my yard, in my yard, and my neighbor decided that she went to light a piece of hellfire. I couldn't stay inside and I couldn't stay outside. One piece of smoke, and like a magnet, the smoke just dip on me like matlock. And I had to call her on the phone and I said, "Is what
Wait,
keep over there?" And she said, "Oh, it's just some leaf I want to burn." I said, "No." I said,
wait.
"I'm gonna."
Leaf in the yard? As in like burn leaf in the yard?
Yes, sir. And I called and I said, "I'm gonna call the authorities on you." I said, "You're killing me off over here." I said, "Oh, it's true, we don't have no bags." I said, "All right, out it." And I went for a pack of bags and I gave her and I said, "Do me a favor. He said, anytime you're tempted to burn, just call me and I'll give you any number of bags you want to sweep up the leaves and put them in the bag and put out at the gate. The garbage truck will take them. The garbage truck take my leaves." So anytime I feel to burn, and guess what? They continue to burn, they continue to burn. It's just, and
Yeah,
then now we have water lock off, and it frustrates me to know that they are using potable water to extinguish the flames,
the bushfire
right?
them.
Yeah. I mean, I have water in my pipe from NWC. I mean, I have stored water in my tank, but there's no water. And they have to use good water when people want to out these fires. People are just selfish and people must get locked up for it. I'm sorry, me have no apologies for saying it. You start a fire and they have to go to NWC for use how much gallons of water for out it. They're supposed to charge you. And you pay NWC to something, don't charge me. But anyhow, we could go on back here because you touch a con that this morning I got up and I started cussing because can't bother yarn. All right, yeah, let's go.
Cousin, sir?
Huh?
Cousin, sir?
Cussing? No, I said cussing.
Yes, that's what I said, if you're a cousin.
Yeah, to myself,
Anybody ever sorry that about the bushfire, Miss Davy?
Yeah, man, I cuss
Yeah,
myself,
but
man.
waiting to ask her if he was cousin.
Yeah, man, I cuss myself, man. I was there walking and said, "These darn people, I don't understand why is it that you're so selfish." I'm saying, "No, cussing,
So wait, they burn it from morning till night?
I guess when they sweep up in the morning, they burn.
No, that's what I mean. Like saying it burned right through the entire day from
It burns for quite a while because I don't know. So and what I can smell sometimes is some plastic that is being burned. And these plastics are carcinogens. So when you inhale them, this is what causes lung cancer and then cancer they will for something. So it's like how some of you guys love to chew well. Thank God they don't have plastic straw anymore. You finish drinking from the straw and you chew on the straw like a gum. You're not supposed to because it's a carcinogen. So when you chew on the straw and break down the straw, you're actually releasing these carcinogens into your system, cancer-causing cells into your system, right?
Yeah.
So and this is why you're not supposed to when you have like the coffin boxes of lunch and you reach home and say, "Sure, I'm gonna go warm up my lunch and eat it in the coffin boxes." No.
If I did that, enough to do that.
Right. The styrofoam, it's good to
Hold
how
heat.
good it is. Yeah, it holds the heat, but when you put it in a microwave and you break down the box, you're actually releasing carcinogen into your food, which is cancer causing cells in the stomach, right? So If you go home with your classic coffin box or the double box for your lunch, scrape it out in our microwave dish, please. Scrape it out and warm it up. Don't warm it into the styrofoam. It's not good. And make sure that you're using a microwavable safe container, because if you use any plastic that is not microwavable safe, you're actually breaking on the plastic also. Right? So there are so many things that we do sometimes unconsciously that is actually detrimental to our health. So we just have to be very careful that we try to stay on the straight and narrow. All right. So we need to look at the function. Now remember, let us walk through how we're going to go ahead and solve this question, or any question on Newton-Raphson for that matter. So the first thing we need to do is to see if it is that we're given the interval. Were we given the interval for this one?
Interval. Let me see.
So is it -1?
It says has a root between 1 and 3.
No, man,
So
hold
you're
on.
talking about the exponential question?
The exponential question cross. Yeah, the exponential question.
Exponential question. No, it doesn't. It doesn't say that. It doesn't. This interval.
Okay. So now that it doesn't tell you the interval, say like the one that cross will just face on screen, where we have the interval between 1 and 3. We know we're adding 1 to 3 to give 4, and 4 divided by 2 is going to give 2. So therefore, my initial
Yeah, work by something.
No, I'm not sharing the screen now. Croswell shared something just now. Whenever you're given the interval, we're just talking through the process. Having gone through the process with you several times, we're now talking through it. When you're given the interval, you're going to be adding the first plus the second, the upper and the lower intervals, and you're going to divide it by 2. So the one that Croswell just shared a while ago, the one that we did last night, the intervals were 1 and 3. So we're adding 1 to 3 to give us 4, and 4 divided by 2 is 2. So my initial iteration is going to be x. It's going to be x equals 2. You understand that, what I just said, class? Are you not following what I talked about?
Sure, like, can you like repeat that?
Yeah, I didn't hear that the first time.
Guys, I did that very question last night. That very thing last night.
Yes, sir, where we add the 1 plus the 3 and then divide it by 2.
Yeah, that very thing.
Oh, sir, that's so when I went over it, that's what I did.
Yeah. So how you say I must go to again. Yeah,
Sir,
man,
because we think you did I say like something completely different.
That's why I said that, and that's why I don't want to show you. I want us to talk it through so that you can remember. Hey, one must learn to talk to himself, and talk through the procedures, And this is what I've also given you. So you will determine the first iteration by finding the midpoint of the given interval if it is not stated. All right. So if when you're given the interval, and say the interval is 1, 3, as in the example we did last night, for the same question that Coswell just posted, shared on screen. In order to find the first iteration, we're adding 1, which is the first interval, the lower interval, to 3, which is the upper one. 1 plus 3 is 4, and 4 divided by 2. And last night I said to you, we will always divide by 2 because we're finding what? What are we finding?
The midpoint, sir.
The midpoint. See down the screen? We're finding the midpoint. This is what I've done?
Sir.
Yes, ma'am.
So is there a possibility that like one time they'll like give it 3? Always 2.
So them can tell the interval between 2 and 6. So the interval they have an upper and a lower. Yeah, man, not going to give it 3. So I'm saying to you, because of this online stuff, I'm going to go out and write out the summary, the things that you need to do in order to get the question done up. So work with teacher. Teacher, try to make them get it. Now, if it is that you're not given an interval, how do we go about doing it again? How do we go about doing it?
Sorry, if you're not given an interval, what's that one? So find 5 or split in half. So we always split it in half. We're not saying nothing.
Yeah, ma'am.
Start from 0 and 1?
I'm coming to that. I'm coming to that response for it. Vision, what do you say? Split it in half?
And that's what I was going to say, because that's what you was explaining last night as well. So.
Because if we get, say for instance, we get the 2 values, say for instance, 1 and 2, because they normally give one value like that. We know the midpoint between 1 and 2 would have a
1.5.
Yeah.
But
So,
that's the midpoint version. You answer for the nether one. The answer for the other aspect, if you're not given a midpoint, and then you say to me, sir, are we going to split something or 2? But that's the one when we just talk about. We want the other one now. So tell me the other one, the other method. Courage gave us something else, but I'm going to come back to Courage with that one. But talk about the other one now.
all right, sorry, go to Courage.
All right, Courage. Tell me, say it again, Courage.
I was saying we start from 0 and 1.
0 to
I
1.
think that's all the first time we did. The first question we solved.
Start from 0 to 1. Then supposing start, okay. That's why I'm coming back to you. What are we looking for?
Third midpoint.
Midpoint? When it start from 0 to 1.
The interval.
No. Yeah, we're trying to find the interval. No, not the interval. We're not trying to
The
find
first iteration.
We're trying to find the first iteration, yes. So that is correct. We're trying to find the first iteration. But how do we know when we find the first iteration? Because we'll end up getting an interval, you know. But how do we find the first iteration? By what?
But cross the x-axis.
Using the formula. Midpoint.
Daily, yes.
X.
And how you know it crosses the x-axis? How you know it will cross the x-axis, David?
Where the value will change.
What value? It change from what to what, David?
0 to 1. 1 to 2.
Value no, the value will change from what?
Negative. Let me write it. 1 to negative 2, sir.
The value will change from what? Say positive to negative. Don't give me an exact.
Oh, positive to negative. Let me jot it down.
Right. So it changes from positive to negative. So you know when it changes from positive to negative, it means that you would have crossed over the x-axis.
So you were hearing me when I said that it changed from positive to negative.
I didn't hear you. Anybody heard her?
No, she never come in.
You never come in.
Oh, Jano. But it's wrong. That's why I'm shut up. That's
No, you never come in, Mom. So it changes from positive to negative. So yes, what you're correct with though, Joe, that we all heard when he said we're finding the interval. Yes, so we're finding the interval, and then Courage came in and said that yes, we're looking for the first iteration. So you and Courage were saying the same thing there. But what I'm looking for here is moving from positive to negative. Very important. From positive to negative. All right. Then the next thing we're going to do is to differentiate the function. We're going to differentiate the function. All right. And when we differentiate the function, what is going to happen is that we're going to be using that formula. X n plus 1, subscript n plus 1. is equals x subscript n minus f of x subscript n over f dash of x subscript n.
So I think that was like one of the first examples I used.
Yeah, man. Absolutely. Yeah, man. That this one was one of the first ones I gave you. All right.
Sir,
Yes, Poppy.
explain to me again. You don't get no value. Where do you get?
You're going to substitute random values into the function. And if the values change from positive to negative, you know that you'd have crossed over your exact value and you'll be able to find this is your exact value. So you know that you know that you're in the positive axis of positive x f of x value sign. So if you're positive, and your positive answer. So if you substitute one value, one random value in another function, and you get positive, say substitute 4 and it's positive, and you substitute 3 and it's still positive, you know you don't cross over the x-axis, because when you cross over this axis here, x-axis, it means that you'd have crossed past your exact root, which is what you want to find. So if you put in, say you put in 2 and 3 and the result is positive, okay. You put in 1 and the result is positive, and you put in 2 and the result is still positive, and you put in 5 and the result is positive. But you put in 0 and then the result becomes negative. You say, oh, that means that the answer lies between this one and that one, because if you put in like -1, and if you put in -1 and +1, and then your values your values change. You put in a not -1 here, but if you put in a -1 over here as the x value, and the value change, the y value change from positive to negative, then you know that you would have gotten your root. Let me show you the example. Refresh your example. Remind again.
Sir, we can still start from 0.
Yeah, you could. So look at this function. So look at this function. Let me spotlight. So this is a function.
It means that why we do this, sir. So
Right. So this is what I'm saying. Tonight is your night to talk to me about what is up, because if I take over the class, it's only in charge of the class. If I take over the class, I reteach everything. And if I reteach the stuff, your questions will still be unanswered. So that's why I want you to throw your questions so I can pick them up. Watch me. This is a given function. I am trying to find out what is happening. So what I'm trying to do, I am going to go 0. I'm going to go 1. And I don't have to start at 0. I could go at -1. I'm just trying to find some random values of x. But when I go to 0 and I substitute 0 into the function, I see, as a matter of fact, I can just look at the function by inspection and see when this is 0, that goes to 0. When this is 0, that goes to 0. So I'm going to leave it at +1. See it right here, so. And then I decide that I'm going to go with 1. When I go to 1, 1 cubed is 1. -4 times 1 is -4. 1 minus 4 is -3. -3 plus 1 is -2. The mere fact, and these values here in pink are my y values, or my f of x values now. The 0 is my x value, and the 1 is my
your y values.
Good. And look at why I use 0 and 1. Because this is 0 right there, so. And so 1, the old summary right there, so. And it's a 2 for argument's sake, and it's a 3, and it's a 4. It means that between this 0 and this 1, the sign is going to change because it crosses the x-axis. All right. Now, so you will see that between 0 and 1, the function would have crossed the x-axis. Why? The value of the function changed from positive to negative. It changed from positive to negative. It's not necessarily the number enough. It's just changed from positive to negative. So what I'm going to do, because it 0 and 1, so this is what Joanna was saying just now. So 0, 1 would be my interval. 0 and 1 will be my interval. So when you're given the interval now, when you have decided what the interval is going to be, and you go ahead and you add the lower values plus the upper value. 0 plus 1 is 1, divided by 2, you get a half. And that's why I'm using my x1 as a half.
Go again,
Yes,
sir.
sir.
Go,
I'm here,
go
sir.
again.
This 0 and this 1 now becomes my interval. Why, sir? Because it's 1. When I substitute 0, it gave me a positive value. When I substitute 1, it gave me a negative value. So I know that my root lies between 0 and 1 because the sign changes. What is the significance of the sign changing, sir? Because
Okay,
it would have
okay.
crossed the x-axis. See here, my
So
exact root crosses the x-axis.
was it all along the answers me I use to try to get that same?
No, and that's why I'm specifically. So
Yeah,
what you're
yeah.
adding is the 1 and the 2. Forget the
Yeah,
interval.
me check me on now. Yeah.
No, at the
Okay.
0 and the 1. That's the interval.
Yeah.
So guess what? I didn't even have to put positive 1 here, saying no, negative 2 right there, saying no. I could have just write the word positive, and I could have write the word negative because that's what I want. I want something that is positive. I want something that is negative to know it past the root. That crosses the x-axis. Once I know it crosses the x-axis, I'm good to go. All right. So the interval is going to be 0 and 1. So I'm adding 0 to 1 divided by 2. I still come and get the 1, the 0.5. And once I get
Question.
uh-huh.
What if you say for instance, what if you start with no man, go back to the top of example. What if you start from say for instance 2? Like the first number random number you choose a 2, right? And then you choose I use 4 are the first number you choose, and then you use 2 for the next one. The 4 have a positive and the 2 have a negative. Can you still use 2 random numbers?
All right. So let's just look at it. If it starts at 4, the mere fact that you have 4 to the third power is 64.
All right.
Substitute. You go ahead and substitute 4 into this.
Sir, am I
All
about me now
Huh?
complete this 0 and 1 we start with my apology.
No. You ask a question. Let us concretize.
All right, so since it's
Substitute 4.
here, x to the third power is a 64, right? So and that would be minus 4 4 bracket 4 to the second power. So let me see.
One, sir.
Right. So you're going to get 1. So you're going to have 4. You're going to be what is it? So you get 1 for up here. And a matter of fact, remember, no, 1 is not what I really want. What I really want is to say what? It's a positive.
They want the x values to be positive and the y values to be negative.
No. When I am guessing, Bijan is guessing 4. But when we substitute 4 into the function, we're getting a positive value. All right. Which other value now you're checking, Bijan?
2, sir. Yes, sir.
Go to 2 now. Substitute 2 into the function for me, please. Somebody say 1 now?
Plus 1. Get
Sir,
1.
1.
Is it 1?
Yes, sir. So that means that can't work, so I have to go again.
What to try? 2?
Yeah.
2 into the equation, isn't it negative 7?
Like it is not.
I probably hold on, I'm gonna try again.
Or I'm gonna do the same thing because I get negative.
I probably I made it wrong. Can I say me miss it to a pat up.
Okay.
When I calculate that,
Negative 7, yeah, negative 7.
Hold on 1 minute, please, guys. 1 minute, please. Hold on.
Sorry, people, man. What me get a 1 negative 7 over. Sorry. I ain't know if you're rushing it, man.
Sorry, guys. I just had a water break. Forgive me. I should have invited you to have a water break, you said. All right. Yes. So you got it to be negative. Let me hear the questions now.
Repeat that.
No, just before I went, just before I asked you to hold, you said that when you tried 4, you got it to be positive, right? And when you tried 2, you got it to be negative.
Negative.
Yes,
right.
sir.
Mhm.
So,
What
sir,
does that
you
mean?
can try any number. You don't have to be 0 or 1.
Fair enough. You can try any number. That's what I was hoping someone would say. And if we try 0 and 1 now, what is going to happen? You know what I want you to do for me?
So that we can ask now, sir.
No. Hold on. I know that's exactly what you're asking, and that's why I asked you to suggest some numbers for me. And that's why when you said to me a while ago that, sir, you know what, I'm just going to use 0 and 1. I said, no, that's not it.
Enough.
No. You're trying to understand what is happening. All right. Do me a favor now.
Sir, we're not done with the 2 and the 4 yet, sir. We may ask now after this if we can use the 2 and the 4 and find the midpoint.
Yeah, but you know, wait until me don't tell you what I'm going to tell you, because that's exactly what I'm going to tell you. So you are now saying to me that, well, based on your understanding, you're saying to me, but sir, your reasoning is that because it changes sign, it means then that I will cross my road. Okay, if that's what it is that you're thinking in your headspace. Because we are in class and we are trying to understand the topic, what I'm going to ask you to do. If you say 4 and 2, all right. So what I want you to do is to start working the question with 4 and 2 and tell me what it is that you get. Go ahead and start working the question with 4 and 2 for me, please. So you're saying that one of the limits is 4 and the other limit is in the interval is going to be 2. So of course you have to write the small one first. So it's going to be 2, 4. So if you're using 2 and 4, that means you're going to say 4 plus 2 is equals to 6. 6 divided by 2 is equals to 3. So that means you're saying that your initial iteration is going to be 3. So your x1 is 3. So now that I help you to find your x1 to be 3, can you start the question for me, please? Start working and let us see how far we get with it. So somebody say something? You must have a mute, not coming on. You're a secret, still. That's my name. Gone somewhere else a while ago. Bless the Lord. Are you understanding what I just asked you to do a while ago, class?
Sir, yeah, tell us, all right, then substitute.
Just replace 0.5 with 3.
Yeah.
Right. And then go ahead and work the question for me and tell me.
So I dash P in a formula when we differentiate and when we have the normal formula over top.
Right.
The P6 of what? Casual?
I want everybody to be working. This is how we're going to understand the topic.
Sorry, so we should replace 0.5 with 3.
Yeah, and then continue working. Yeah.
Okay, cool.
Which document is this, by the way?
No man, is the one that one of the first documents that I sent. So you okay? So what? Look at the screen here. So instead of you, what author you just asked a while ago, and Davey and the rest of them in that, we're not using x1 to be 0.5, we're using x1 to be 3, based on the scenario that Dijon just did in class. So we're using
Yes, sir. Hmm.
So how many iterations should we find using the 3?
and I was hoping that somebody would have asked that question. Why are you asking that, Courage? I'm not being I'm not being cheeky. It's a genuine question. So I don't think that I'm being cheeky when I ask why you ask me that question.
I'm just asking because I just started.
Oh no. Okay. Do a few iterations and then come back and ask me that very question, Courage.
Okay.
Cool.
Origin, I'm going to I don't want to share the answer now. We get 3.8889 for the first iteration. We get for the first iteration. Probably do something wrong, you know.
In a way off.
Isn't the first iteration 3?
I may get some wicked negative, long, some big number.
That's after the second iteration. Look at me, I do something.
What are you guys doing? I don't think I understand, right? You have to replace this.
So my first iteration, I get negative 2.6668.
You mean second
That's a
iteration?
negative 8 divided by 3. And
But I do something wrong.
Wait, isn't the first iteration 3? Since we have to replace
yeah, man, the
0.5.
first would be 3, and then the
It's a negative 8 divided by 3, right?
The first will be 3 and the second will be negative 2.668.
All right, in our last part of the equation, negative 8 divided by what is it?
3.
Let me get that different number.
I said negative. I said
Yes.
negative 2.66.
Minus the 3, the first iteration. Don't forget that.
Yeah, so I got 5.667.
Yeah, same here.
What is it?
Let me check.
Which
Let me
iteration is that?
Second one.
Second one? Let me check.
Second one?
Second one.
So is that the second iteration we must start at? Because if certain we use 3, that means that would be the first one.
Yeah, we did the first one, which is 3,
Yeah.
and then we're supposed to do the second one. We're supposed to substitute the 3 in it.
Oh,
And
wait.
I got 5.6.
I use 4 when I.
Sir.
Yes, sir.
We get marks for step.
What do you say you got for the second iteration?
This one and revision.
This not safe. This the answer them I get.
Second iteration.
It's not safe. Me not sure myself. Hold on. Courage. Hold on, courage. Courage, you there? So let me hear what I reason the car. She there? Hello?
What?
Let me hear what I reason there. So we use 3 for the first iteration. So you have 3 minus. So I gotta use the equation. So I got minus 4 bracket 3 cube plus 1.
Square plus 1.
Is it supposed to be 3 to the cube minus 4 times 3 to the square plus 1?
Yes, that
Yes.
yeah. All
It's
right.
supposed to get negative 8.
Yes.
All right. Over 3.
Yeah.
the
From the
differentiate that, you get
differential.
3 bracket 3 to the square minus 6.
Wait, where you get 6 from?
If you differentiate 4x squared, you know, got times the 2 up there, so by the 4 there, so.
That's it.
Yeah, that's
4, 8 to rocket. That one, man.
yeah, and then
Come here and say, when me I go wrong, you know. All right.
and then
Hold on, man. Yes, me not. This one.
what are you say, boss?
Yeah, so you say 8 this one.
Andre Francis, I've not been seeing you in my class, sir. I saw you once and I don't see you again until now. Come on, you are very silent. You are not a part of this conversation.
Okay,
Come
now
on.
we get the cheat. No, sir.
Rajay, you are silent. Tariq, you're not the same Tariq that I met last semester, you know. Something is happening, Tariq.
So I can't be talking and I work such questions, to be honest. I'm just
No,
trying-
but I mean, on a tonight alone, I have a concern. I have
No.
a concern from before.
No concerns here. I'm getting work done.
Okay, thank
Okay,
you, sir.
all right, me get the 5.66.
Sir, may I do a catch-up thing, you know?
Mhm.
All right, explain the next process.
You're going to use that 5.66 now as your
Yeah, and then put it
value?
in the same way. I just did,
Put-
I mean,
yeah.
wrong man. The 4 times 4, 2 times 4 and get 6 with the self. That me do wrong. So thanks. That's why me want to go through it.
Wait, how you get 5.66 again?
Because you have the 3 minus the minus 8 over the 3. So you put that in a calculator, you get 5.66.
Wait, 3 minus, where's it? 3 minus the
3 minus, and then you're going to
bracket
put
minus
bracket
8 minus
Mhm.
8 over 3.
over the 3, close bracket.
You get 5.6666. 1%. Say that's 5.667.
Rajay, you're not part of this conversation. Tajay, I'm not hearing you either.
So that
Sir,
means
sir, I said I'm doing a catch-up thing, sir.
Oh, is you this say you didn't catch up thing?
Yes, sir.
Oh no, I thought it was Andre. So Francis, I still don't hear from you. I thought it was Andre who said that. Mr. Francis, good night, sir.
It's 5.66.
I'm doing cooked up this, sir.
yeah, 5.66.
All right, then cool. Come on.
Yes, sir.
I don't understand. You not talk.
Dear God.
Yeah, but they understand, sir.
More
I know
participate.
data is
Situation now.
so.
Almost 8.
Anybody do the fourth iteration yet?
So far, we go.
Yes, sir.
Okay. Are you seeing anything close?
Well, I went up to the 5th and 6th iteration. I realized that the 5th and 6th iteration are the same. So I stopped at the 5th.
The fifth and the sixth are the same?
Yes, sir.
And what is up for the answer there?
Wait a minute. Wait 1 second.
Sir, that means it. Oh, you know when you have to stop, sir.
Wait a minute.
But what I remember, sir, I would
No, I know.
that
I think at the 6th
you
and
would
the
stop
7th.
when both values match each other, something like that.
Very good. When both values are the same, you can you stop. Very good process. Mikey, what you say now? You do what? The sixth and the seventh are the same? So you stop at the sixth?
Yes, sir. I don't reach there as yet, sir. I'm still working on the third.
Okay, sorry, it's not Mikey. Who was saying? Oh, it's Tajay.
Yes, sir.
Hey boy, it's one like next. So the two of the same mother? Our father? On the son alike, man. On the son alike. All right, Tajay. So you say that you finished the you do the sixth and the seventh already. So you stop at the sixth iteration, you know?
Yes, sir.
And what is the value for the sixth iteration?
I got 3.9354. That's what I got.
3.9354.
Yes, sir.
Courage, oh, that look courage.
I'm still in the fun.
All right. So okay, thanks, Taj. All right, the rest of you continue working and let us have a conversation on this. Because I know exactly what is going to happen. Taj, in the meantime, I want you to just double check some stuff and just make sure that your answers are on point.
All right, sir.
Cool.
Hey, courage, you get 54 point something over 51 something.
Huh?
In a second iteration. Come if you let me do something.
You mean third iteration?
Why? Not even know which number this is.
54.5253.
Got 54.5202.
All right, when you plug in 5.6667, that will do, right?
Yes, yes.
Right, finish it. 1.66.
For the third, I got 4.598.
Yes.
Need.
So you say 4.5971?
No, 4.598. Remember, if you have to round it off here.
Okay, all right. That.
Christ. So the third iteration will be 5.66667 minus
Right. All right.
Christ, how many right for the
Third iteration.
It's 54 point for some
The 54.5491 over 51,008. That as well.
Sorry, repeat that.
54.5491. That as well.
Yeah.
You get my brother like that too. And them say, yeah, it leads me to the 4.598.
No, the third iteration myself for.
Oh, I'm not over again, man. Not even
It's supposed to be 5.667 minus
Okay. Sir, how much master procedures? Mm.
And what you say was the answer for the third iteration?
Courage, are you my talk to
You get mark for procedure, man. Anybody else reach where Tajay reach? Anybody reach a fifth one?
No, sir, I'm doing the fourth.
No, sir, I'm still on the fourth.
All right. Then.
Courage, what?
Courage. What did you get for the third iteration?
You say?
The third iteration. What was the final answer for the third iteration?
I got 4.5977.
4.5977.
Yeah.
Tajay, did you get that?
No, I look at it, I didn't round. Huh.
That is what I get.
Yeah.
And it was 5.66 minus what exactly to get the answer?
Minus 54.5253 and 51.0034.
So say 51. Say 51.
Decimals are different from mine.
It's the same answer you get, I get.
So say you got 51 by what?
51.0034.
Over 54.484.
The 54 is on top. The 54 is the numerator and the 51 is the denominator.
I see.
You know, so from the semester, this is the first real class we have when everybody at all, and I love it.
Sir, because they're afraid to ask Courage. You know, I show up myself, Courage, know the answer.
Me love the class tonight. You know why? When I talk, I mean, I get information out on you know, this me now, you know, pray laugh me laugh. Yeah, man, I love the sound of it, man.
Why the third answer on it?
Them say 4.59 something. 5977.
Look like me get my marks if a procedure card.
4.598.
4.59.
Touch them right?
You using three, no, she's using 3 decimal points. We are using 4.
At this point, I'm kind of confused. I'm going to redo the question.
Yeah, because on my fourth iteration, I got 4 point something, but you say you got like
4 point, Courage, I got 4.727. That's what I got.
my fourth, I got 4.08.
I don't finish yet, man, Courage, so you're not
Oh, Jesus. All right, Courage, have the same answer with me.
For the
All right,
fourth,
let me ask you one question. And this question I really hope. I know you guys are going in circles, and deliberately I'm allowing you to go into circles because I want you to understand what is happening. If I tell you don't touch your pot because you're going to get burned by it, you're going to go there because you want to touch your pot to get burned. When you get burned, you're going to say, nope, not touching that pot again. Well, hopefully. I hear you say something about the third iteration. You're getting 4 point how much?
4.5977.
4.5977. And for the second iteration, you're getting what?
For the second one, we get 5.6668.
Okay, let me ask you a question. What's the interval for the that you evaluated? You're saying that the answer is supposed to lie between what and what? No, 2 and 4.
2 and 4, sir. 2 and 4.
All right. So if your answer is supposed to lie between 2 and 4,
and you reach a 5.
And you reach a 5, you know it's sitting around. Talk truth.
When you say you get lucky for the second one,
5.6668.
That means we're not gonna reach a what's it called? Oh.
What did you get, Courage? 5 too? So you have a decimal point now, right? If 5 wrong. Okay, we'll
So,
pass.
sir, no, maybe me I get this step,
Just
step
mhm.
wrong. I have 3 minus 8.5 divided by 57. I get 2.8596.
No, you're supposed to have 3 minus -8 over
Over
Yeah.
3.
yeah, or 3.
But please, when you're doing that, Otterly,
Yeah.
use a parenthesis. So write 3 minus
Oh,
open
yeah.
bracket -8 divided by 3 close bracket.
Yeah,
So,
yeah.
so Alterly calculator can do it without
Yes,
that
yes,
because you have
yes. I forget
the
you have
fraction.
the good type one. Yeah, you
You
have the good type one.
fraction.
They say it's 4 point, say saying for the fourth iteration is 4.598.
We're not supposed to reach nowhere. Can we pass it?
No, which is what no, I'm going to answer the continue with the question, you know.
Oh,
Continue and see if you're going to come back down. But I'm just saying to you, Vision asked a while ago, sir, when we're supposed to stop, and I didn't answer, and then Crosswell says when 2 successive iterations are the same. But I am now putting something in the mix to say to you, if you're saying to me that your interval is between 2 and 4, the answer is supposed to lie between 2 and 4. That means that
You can't get
the
no
first iteration was the closest. The second iteration at 5 point something is wrong. That is outside of the boundary.
Yeah,
The fourth iteration, which is 4 point something, is outside of the boundary. Tell me what the fifth iteration is.
Outside the boundary. Most outside though.
Tell me what the fifth iteration is.
Courage, where are you?
yeah, calculate that for courage.
Just done 4.
Tajay, what you say? You just finished 4?
Mikey, sir, Mikey.
Listen to me. If the tone is on like one more time.
So, sir, you're
Yeah,
saying
go ahead.
that when we're doing the iterations, fall outside the 2 values where we use, they're wrong.
Because I am saying to you that my answer lies between 2 and 4. My answer is going to be anywhere between 2 and 4. If it falls short of 2, it don't lie within the interval. And if it's over 4, in the interval, if it's outside of the interval.
So the answer should be resting between
2 and 4.
So I mean the first iteration was
the closest, but they can't use the first one alone. And then when you use the second one, you get 5 point something. Use the third one, you get 4 point something. That's why I want you to continue. So Taj, when you did the 6th iteration, what was your value, Taj?
Sorry, I got 3.95. I'm gonna go. I got 3.9354.
Okay.
So yes, no, sir. That drop in a interval there.
But he needs to do. He says that he did the 6th and the 7th, and both 6th and 7th was given the same value. But I suspect that he was making some miscalculation along the way, because he said that he was doing it over, and then he recorded a different value than what he got before. Right, Taj? One of the values, one of the iterations he got when he did over the question wasn't the one what he got from before. True or false?
No, sir. I'm still redoing the question, you know, because
okay. I get you, puppy. But what I'm saying to you, you're redoing the question. So far in the redo, are you getting back the same answers as you had for the first one?
Yes, so far at the third iteration.
And what do you have for the third iteration?
4 point. Well, I'm gonna ask a quick question because I rounded off. I rounded up the 7.6 at the end, the 7.7, and when I did the fourth iteration, I got back the same. If I'm seeing it right, I got back the same thing that I did previously in the first attempt.
Okay, all right, that's fine.
So I think it might be okay so far.
How many decimal places are you using?
I'm using 4 decimal places, sir.
Okay, all right, good. All right, continue working and see what comes out to be.
Let me apologize to the class.
No, and I'm happy for it, because there's something I want to say that I'm not going to say yet. I'm happy for it because there's something I'm going to say that I'm not going to say yet. I want you guys to see it first. I said a piece of it earlier.
So me just ask the question, what if me in an exam and me can't remember say 1 and 2 and me just drop 2 numbers in it?
Uh-huh.
I say,
Uh-huh.
and them
And then you see, and then now put it this way. You need flour, you make fritters, and you need and your consistency not right. And you take out one batch and you put in another hot oil and see it start spread well, like nature type. And you don't have a fritter there, you have scrambled egg or you have egg well run. So there's a method to the madness. That's the point I'm making. And I want you to do what it is that you're supposed to be. And I showed you one thing already. You notice so far all the iterations that we have, all the questions on Newton Raphson that we have been doing. Every time we do the question, the first iteration may be off, but by the second iteration, we're getting very close to what it is that we're supposed to be doing. And by the third iteration, we're getting even closer. So think of the example I gave you before. Somebody got abducted in New Kingston. And if you decide, say, you know, I'm going to start from Golden Spring, vision that is for you. You are just picking some random values. So you start from Golden Spring. And I'm saying to you that the abduction occurred in New Kingston. But because you want to be hero, you just say, no man, they're the wickedest something in the police force. You just start from Golden Spring. And you don't even call upon your friends then, New Kingston and say, yo, Roops. And the New Kingston people them don't call Rockford and call Matildas and call Happy Tree. Closer to where you are, because by the time you move from Golden Spring, the traffic will come down the hill to reach down in New Kingston. This is when they reach a Portland long time. Long time. So you have to be very strategic. If you start too far out, the calculations will tell you that you are outside of the boundary. So based on what you guys are telling me now, that's exactly what it is that I'm getting. That you guys are outside of the boundary. So continue for me. I want to see how quickly you guys can go up to about the 8th iteration. When you get to the 8th iteration, we're going to stop and then I'm going to talk about something else. Continue quickly, please.
Christ.
Only so silent. I'm not even hearing nobody breathe.
Good day, yes, sir. Good day.
Okay, cool.
Anyone got 3.946 for the fifth?
Yeah.
What did you get for the fourth?
I think that's what Courage got.
Yes, 3.960.
60. Mm-hmm.
I'm using
That's what I got for
four.
the fifth.
Well, no. What did you get for the fourth iteration?
I have 4 points.
0.0859.
I did make some miscalculations and
Oh, sorry, the eighth iteration is giving us the figure by with the 10 to the -4. Times 10 to the -4. Reach to the answer.
Into the -4.
The long number times 10 to the -4. It's a negative number, -4.8.
I so respond to your Francis senior message. Type the answer in the chat for me, please, David. And let me ask you a question, David. None of your two iterations come out to be the same? Hello?
So I think
Yes,
the
sir, but
6th and the
decimal
7th
place.
are the same.
Yeah, the 6th and the 7th. 9.3 and 9.3. 3.93 and 3.93. How much decimal place is that? 2?
3.93. Let me see. Okay. Let me go to this one. God, my internet just keeps dropping and just reconnecting. That's happened 2 or 3 times in the class before. Give me the, can someone read the function for me again, please? X cube, is it X cube?
Yes, x cubed minus 4x squared plus 1. So that's x cubed minus 4x squared plus 1.
People, where you say that the values are similar, the fifth or the sixth or seventh iteration.
6th and 7th.
Okay.
All right. Let me wrap this up. Let me wrap up this conversation pretty quickly. All right. So very good for those of you who 3.9. How much you gonna get? 3.9. Hold on. Let me tell you what it's supposed to be. 3.936 or 35. 3.935. Anybody got that?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. That's what I got.
3.6 or 3.9.
Okay. All right. Great.
Which iteration is that?
That's the fifth.
Six. The fifth one? 6th and 7th.
Oh, 6 or 7. Okay.
All right. Where do I go? Forgive me. Hold on. Where do I go? Where am I? Okay. Application of differentiation. All right. So are you still see my screen with the question?
Yes, sir.
All right. So when we did the question, we were getting my third iteration, we're getting 0.53, 0.53, which would be 0.54. If I'm using 2 decimal places, how many decimal places did it ask us to go? It didn't say here. This is an example. It didn't say, but anyway. So if I stopped at x3, x3 saying to me, that means that I'll be using 2 decimal places, 0.54 and 0.54. So to 2 decimal places, this will give me 0.54, 0.54. And then I could stop here because these are correct. All right. Now, those of you who got 3.935, you are also correct in with the iteration. And in the way say, Lord Jesus, then sir, oh, we know what we do. Let me explain what is happening.
No, but
here.
sir, it's like
Mhm.
6. 6 give us 3.936.
Mhm.
And then 7 give us 3.935.
That's fine. That is fine. That is fine. Because if you run it off to 2 decimal places, you'll get 3.94 for both. Don't.
Yes, sir.
So,
Yes,
alright.
sir.
So look at this graph. Look at this is my cubic graph. X cube. Let me just go to make sure that it is the something normal. Oh, the drawing tool that is there. All right, make it stick. No. A pointer. All right, just to show you, that's my function x cubed minus 4x squared minus 1. All right, that's correct.
Yes, sir.
Yes, sir.
All right, good. Now, look at what I want you to see what is happening. I use the point between 0 and 1. Everybody see that? I use the point between 0 and 1. Yes, no, talk to me now.
Yes, sir.
All right, good. Between 0 and 1. So I'm saying to you then that this point here is 0.537. What did we get? What did we get in the question that I sent off to you from the document? Was it 0. I think we said 0.54 when we round up to 2 decimal places?
Zero point 0.4. 0.4.
537, yeah.
0.5. Okay, great. But if you look at this function here, this cubic function, you recognize that it cuts the graph in 3 different places. 1, 2, 3. Talk truth. It cuts the x-axis in 3 different places.
Yes, sir.
Yes, sir.
Good. So if you use the iteration between 0 and 1, your answer as 0.537 is correct. Bijan says, you know, sir, we're going to try from 4 to 2. And then now when you do the iteration, it went over to 5. And when it went over to 5, I said, but that can't be because it is outside of the limit. And then you went down to the 6th and the 7th one, and it came down to 0.935, which is also a correct value. But I also say to you, if you use your value between 0 and -1, or -1 and 0, because the smaller one comes first. If you use your value between -1 and 0, that means your first iteration is going to be -0.5. You'll end up getting -0.473 as one of your answers. All right. So if in this question, nobody told you to use the limits between A and B, and you decide to use the limits elsewhere, and you get any of these 3 values for the solution, for the root, as I call it, you would have been correct. So those of you who did at the 3.935 would have gotten full marks for the question. When I did the solution and I got my 0.537, I too would have gotten full marks. When somebody else did the question, I would have gotten -0.473, they too would have gotten full marks. Now, let me explain what it is that I did. In that very first example, you notice that was the first example I used. What I did was to show you what it is that I'm doing for my how to find the intervals of the question. So me use 0 and 1 and the sign change from positive to negative would have suggested that there is a root that lies between 0 and 1. When Bijan did the stuff and says, sir, I'm going to try between 2 and 4. Between 2 and 4. There's a root that also lies there. And then somebody might say, but sir, me never tried 2 and 4. I tried 3 and 4. There's a root lies right there. And also somebody said, but sir, you know, respectfully, you know, them are the bright ones in the class, but me try -1 and 0 and me get a root, you know. You would also be correct because this graph has 3 solutions. It cuts the x-axis in 3 different points, point 1, point 2, and point 3. Are you following me?
Yes, sir.
All right.
Yes, sir.
Let me go back now to show you something here. New share. Let me go back to show you something here. Do you see my graph right here? How many times did this graph cut the x-axis?
4 times.
Really? Look.
One time.
One time.
Exact root, one time.
Yeah, one time at the exact root. So there's only one solution to this question that I gave. Only one solution to this question. Only one solution to this question. But in the question that based on this example that this graph that I generated with the different iterations, there is only one root. So the point is, one may say, but sir, why did you use that example? The point that I was bringing across from this question is to show you that when the graph crosses the x-axis, I'm finding what? My exact root. This question has just one root to the solution because it cuts the axis one time, as opposed to this graph where the graph cuts the x-axis 3 different times. One right here, so right here, so and right. So how many roots do I have for this question?
3.
Good. When you look at the question up here, so what is this value here, so?
So repeat that.
What is this? Yeah,
3.
And when you see a value like that, when you see x cubed, how many solutions it tells that it has?
3.
3.
Very good. It has 3 solutions. So that's why I was laughing so much, because I knew it has 3 solutions. But when I selected 0 and 1 in my original explanation of the question, I am selecting this root. You may say to me, then sir, how we will know which root to use? Okay, don't rush me yet. Do you notice in my second question, I'm saying to you, it has a root in the interval 0, 1. Talk truth.
Yes, sir.
All right. When we transpose this equation, x cubed, I know Chanel not here tonight, she sent her apologies. But when we transpose this equation, x cubed minus 2 plus 2x, all right? Somebody remind me of this, please. X cubed minus 2 plus 2x.
Wait, you want us to differentiate it?
No. Just remind me of it. X cubed.
X cubed minus 2 plus 2x.
Thank you, sweetheart. X cubed minus 2 plus 2x. All right. So that graph is in blue. That graph cuts the x-axis how many times?
Exactly. What? Where it
Just
is.
one time. So look at that example. It's not
Yeah.
so it cuts it once and it cuts it between
Up is less than 1.
0 and 1. And that's what the question says. 0 and 1. So guess what? In this one, I am getting my exact root to be 0.771, I think. Yeah, 0.771. I'm getting that to be 0.771. That question, let us go. What did we get our answer to be? 0.771. Talk truth. You see, both of them are the same thing. 0.771 when you round off to 3 decimal places.
Yes, sir.
0.771. Bijan, me don't like when it's silent, you know. When it's silent, you know, learn.
Observe, me observe. Then say me not getting me a make nice, sir.
Okay, good. So you see how I get my 0.771 based on my Newton-Raphson here, so when I look at my graph, I can see, I could have told you that my answer is 0.771. When I plot it on my graph is actually giving me the 0.771. But in this case here, in this case, come on, Mr. Shan. In this case, when one sees this cubic equation, one is going to say, oh, it has three answers. Which one do I use? They are telling you which one to use because this graph only crosses the x-axis once. This graph, it looks like it has a saddle point and not a turning point. Well, one of the turning points is going to be referred to as a saddle point. And that point is based on the graph that I look at, and it's not a maximum or a minimum, so to speak, as in the case with the other graph that I have projected, where you have one being maximum, one being minimum, so that it crosses the let me show you what I'm talking about. So this here is going to be a maximum because it turns down. So that means we can cross it here. So turn and cross it right here. So again, and then I would have had a minimum. Oh, come on, pointer. I would have had a minimum somewhere right here. So it means that the graph comes back up and eventually crosses an immediate and automatically crosses this point here again. So once it is that you have a maximum or a minimum, the graph is going to cross it 3 times. This blue graph does not have a maximum, does not have a minimum. Are you following what I'm saying?
Yes, sir.
So it's not going to cross it 2 times or 3 times as the red graph. So the blue graph crosses clearly only 1 time at 0.771. All right, and the final one I'll do before we move out is, let me look at example 3. I know we don't do the homework one yet. I may just send it off, the solution off to you, but it's important that we went through this thing here. X cubed minus 3x minus 4. X cubed minus 3x minus 4. What was it? What was the function again? Forgive me, I lost my thought. X cubed minus 3x minus 4. X cubed minus 3x minus 4. X cubed minus 3x minus 4. Okay. All right. Look at this graph now. All right. You see this green? Am I confusing with so many graphs on it? All right, let me deactivate it.
Let me just like a save.
Right. All right. So let us look at this graph here now. This graph is it has a maximum and minimum also. This is a maximum. This is the minimum. All right. Look at what is happening. How many times, what's the exact root of, how many roots it has? How many roots this graph has?
2, sir.
How many roots the graph have?
I just came back, sir. What's the graph formula?
No, tell me. Look at the graph and tell me how many roots it has.
Three.
That looks like 3, sir. Wait. 1, 2, 3.
One.
It has 1 root. And this is a root up here. Remember how we cut the x-axis, guys. How much time must you know? Is where it cuts the x-axis is a root at 2.196. It cuts the x-axis at 2.196. Can you remember that? Is where it cuts the x-axis is the root. 2.196. All right. Teacher, alpha is equal to 2.196. Is the exact root for this function. Any questions? Are you able to relate the graph to the function now? I know you're not going to have a graph in the exam.
Yes, sir. That was just the accident.
You're not going to have a graph, but this is just for learning purposes.
Yes, sir. Then not ask for make a sketch.
For the Newton-Raphson? Maybe
No,
not
no.
for the Newton-Raphson. No.
Ah, sir, nobody with that excitement. Please.
No, because I'm going to tell you why. Because they're not going to have any turning points and then something there. So no, not for the Newton-Raphson. So the Newton-Raphson just going to give you the exact roots or roots for the graph. So can you see how I get how the roots of the graph correspond to the graph itself? And what I mean by the roots, when you're finding the roots of a function is where the graph cuts the x-axis. So sometimes they will say to you, so let me go back to this one here now. So if it is that they're not giving you the Bijan, let's go back to your sum. What if they had written a question as vague as the example? And my first example wasn't vague. You notice my first example didn't even have any write-up. I just gave it a function, true or false.
True.
My compared to my example 2, that I will tell you what it is that I want you to do and how many decimal places. And my example 3, you give it a write-up and tell you how many decimal places. And my example 4 has the same stuff. And then I gave you a do now, and it still have some instruction. My example 1 just gave you a function, without any write-up, because it was just to bring across the point that if you're given a function without the limits, the interval, this is what we need to do. So let me say to you, what if you're given a function with several intervals, and say different ones of you in the class did it, and somebody say, you know what, I'm going to try 0 and 1 because sir did 0 and 1 and got your answer. And Bijan say, no, I'm not try 0 and 1 in them. I think outside of the box, I'm going to try 4 and 2 or 2 and 4. And then somebody decide that they're going to try -1 and 0. All three of you get the stuff. All 3 of you get the full marks. But whenever the questions are of such that we know that there are multiplicity or multiple values or multiple solutions to the question, then it is that we'll say a root lies between 3 and 4. So I wouldn't even go 2 and 4 vision as you hypothesized earlier.
No, sir, enough, you know.
No, man, and I'm happy for it because I'm hoping that
0
this
and 1,
exercise,
sir. 0 and 1.
no, Bijan, I'm going to tell you what happened. I would not have gone to the graph to do any further explanation. So based on what you asked, I was able to go to the graph and try to give more clarity to what was happening. And it comes back to the point. That's why we need to open the mouth and not open yourself and talk. Because what it does, it affords me to give an opportunity. It's just like when I go to the doctor, and the doctor says, okay, what is happening to you, doctor? I don't know. I just not feeling well. The doctor will go start from scratch and they have one for something. Now, if you say to the doctor, doctor, I have a pain in my head, a pain in my foot, a pain in my hand, it narrows what the doctor now has to do, and the doctor can diagnose you much quicker. If you tell the doctor, say, boy, doctor, I just not feel good in my body now, doctor could say, all right, go do an MRI, go do this, go do this blood test, and the doctor now has to have this a method of trial and error. And you can visit the doctor so many times until the doctor is able to arrive at something. So as you have to get closer and closer to what it is, so it is that you can decipher what the answer is. Same thing with what it is that I'm just saying to you. If somebody gets abducted and you decide to just start from Montego Bay, hello, the person will reach Cuba before you, or Florida before you, yes, Cuba too, before you move from Montego Bay to Kingston. Because if you send a shuttle driver another take hour and a half to come, the flight to Florida is an hour and 20 minutes, right? And never fly over Cuba. So of course you reach Cuba long before you reach Florida. So I'm saying to you, you have to be strategic to see how close you can start to your exact route. And the question will give you. So don't have to worry that you have to be jumping all over the place. The question given is not going to be one open-ended like the one I gave you as an example. What I gave you as an example is bring across a particular point, right? If you look at the other questions I gave you, they would have actually given you more information so you can pinpoint what it is that you're supposed to be doing. Finally, what is also happening is if they don't tell you when to stop at the third iteration or the fourth iteration or the fifth iteration, just like what Tajay, the first person to complete the stuff, and then others follow suit, Tajay said, sir, my sixth and seventh iteration are exactly the same at 3.9, whatever, 3.5, whatever it is, right? So he knows that those two iterations are, it does not necessitate him doing an eighth iteration, because the sixth one and the seventh one came out to be the same. It means that the eighth one with Jean will come out to be the same. So will be the ninth and the 10th and the 11th. You know why? Because I have found my route already. I have found my route to the question, and it's going to give me that. So don't be alarmed that then sir, I don't know which one to start. Don't be alarmed. The question that we write will tell you where to start. It will give you information that it lies between this or that. And if it is that we're asking you to do stuff, we are going to give you where it has only one route. So you can't be all over the place. And my final stuff that I will say, I'll take your questions after, but the final thing that I will say is, if it has one route and you guess outside of that route, say the route lies between 1 and 2, and you guess between 2 and 3, every iteration that you do will not converge. It's going to diverge. Diverge means that it goes away from, converge means that it comes towards. So if when you reach the 6th and the 7th iteration and it's still diverging, it means that you're far off. You have to wheel and come again. All right? Questions? All right. I guess you have none.
So we still don't touch a question.
You know, I am going to, all right. You want to give me 5 minutes or you want to sleep?
Can give you 5 minutes, sir.
All right. Give me 5 minutes. All right, so it says find the solution of f of x equals to x plus e to the x near x equals -1. All right. You see what I'm saying, Jean? I'm telling you that this one is near x equals -1. So it means then that I'm going to use my initial iteration as x equals -1, right? So it is near x equals -1, and I want to do it to 3 decimal places. So my first iteration is going to be -1.
Okay, so that would have appreciated if in an exam then give you the number we start with R.
Oh, that's what I'm saying to you. You see,
Yeah,
when I'm teaching, you know, I can't just, okay. So what I'm saying to you, why I'm teaching you both methods, I don't know how CCCJ will set the question. I don't know how they will set the question. So I have to set the question in such a way that I'll have to show you how to go ahead and calculate the values, the interval, if it is not given. Because I don't want them not give you the intervals and then you run into problems and say, boy, sir, the teacher topics on whatever the situation. But you know, but you have to do what it is that must be done. All right. All right. So let's go. So what happened now is my second iteration is going to be I'm evaluating my second iteration. So what, remember, I'm going to be substituting my values into the function. I'm going to be substituting value into the function, into the original function. So everywhere in the original function I see x, I'm substituting the value. So this becomes f of 1 is going to be equal to 1 plus e to the, sorry, not 1, but -1. It's -1 here. Don't follow me. It's -1. So f of -1 is going to be equal to -1 plus e to the -1 plus e to the -1. See it right here, so 1 plus e to the -1. When you put all of this into your calculator, you should end up with -6.0, sorry, -0.6321. All right, you're going to differentiate the function. So let's differentiate the function. F dash of x is going to be the differential of x is 1. And the differential of x, of e to the x.
E to the x. What?
It's going to be e to the x.
E to
The
the
differential,
negative. Yeah,
no,
e.
the differential of e to the x is e to the x.
E to the
Remember?
x.
Right, so it's going to be e to the x. So so when we do that, hold on there.
Oh, you have it now.
So when we differentiate e to the x, we're going to get e to the x. Differential of e to the x is e to the x. Hello, are you with me?
Yes, sir.
Right, so the differential of e to the x is e to the x. So I'm going to have 1 plus e to the -1. 1 plus e to the -1. And when I do 1 plus e to the -1, I'm going to end up with 1.3679. I'm going to end up with 1.3679. So I'm going to substitute that into my function. I'm substituting that into my function. And when I substitute that into the function, I'm going to end up with -1, which is my initial, minus the -0.6321 up top over this 1.3679 down the bottom here. So my x2 value is going to be -0.5379. And the process continues. I already have my differentiation. I'm going to substitute this -0.5379 into the original function. I'm going to get 0.0461. I substitute it in the differentiation one. I'm going to get 1.548, 840, sorry. When I substitute that into the formula, sorry, I'm going to end up with a -0.5670, right? So you're doing the process several times over and over. The only thing that I believe you got a little nervous about was the mere fact that you got an exponential function into it. Don't be alarmed at it. You know that when you differentiate the exponential function, the differential of e to the x is e to the x. Right? So you don't have to be alarmed at that. Differential of e to the x is e to the x. All right, so the differential of e to the x is e to the x. All right, now, and then you can move to the fourth iteration by using the third. Into the fourth iteration by using the third, and you're going to substitute it in the original, into the differential. You get your values out. You substitute it into the, you know what your x your x, then this is not necessary right here, so because that's the x1. You know what your x3 value is going to be. Yes, and I end up getting both answers to be the same as negative 0.56, sorry, 0.5670, and I get x3 was 0.5670 and x4 is 0.5670. So I don't need to do another iteration because I would have found my values from there at the fourth iteration, right? So what I believe you guys got a little concerned about was the fact that you saw an exponential function in there and you said, well, I can't do that one. But don't worry about it. Remember, you are, once you get your first iteration, you remember you're substituting the value of the first iteration into the original function, and you're also substituting it into the differential function. Differentiate the function. You know how to differentiate e to the x. The differential of e to the x is e to the x. Matter of fact, if I'd given you e to the 2x, the differential of e to the 2x is the differential of the function times the differential of the overall function. You know how to do this stuff. So I'm going to send you the solution to this one so you can look at it a little bit more closely over the weekend, and then we should, if all going well, we should meet on Tuesday, God's willing. All right?
All right, sure.
Okay,
All right. Let's do it. Thanks for coming out and giving me the extra time. All right, take care, guys.
Yes, sir. Thanks again.
Come on. Yes. Papa, take care.